So today I'd like to tell you a story about building something new from scratch and then scaling it over for almost a decade. So in 2014, Zemanta was still a very small startup of just 25 people. And we already had a successful product, but the growth of that product was kind of slowing down, and we knew we had to find a new direction for the company. And so after some consideration, we decided that we are going to build something completely new. And this new thing was called native DSP, which is essentially a fancy way of saying that it was a very advanced advertising product which marketers and brands and marketing agencies can use to reach millions of highly relevant users with their ads. And so probably the most interesting part of that is a thing we call the real-time bidder. And this essentially is a very complex piece of software that's connected to a bunch of ad exchanges through APIs and whose job is to buy ad space in real time. And in other words, what this means is that every time you visit a website, all the ad space on the page you're looking at is put on an auction on one of these ad exchanges and then sold to the highest bidder in real time, just a fraction of a second. And this highest bidder, the winner of this auction, then gets to show you their ads. So the most interesting part of that, for engineers at least, is the scale, because the scale is absolutely huge. As of today, this system processes over 4 million bid requests per second. It also generates and processes over 150 terabytes of data per day. It involves a bunch of highly advanced machine learning algorithms running in production, doing predictions in real time, and in total, they do over 1 billion predictions per second. When I asked my team about that and they told me this number, I was surprised, to say the least. And even though the system is designed to be highly efficient and very highly optimized, it still runs on over 1,000 very powerful machines spread across 5 data centers on 3 continents. So if all of this isn't telling you much, I can try to put it another way. We process 40 times more bid requests per second than Google processes searches in the same time period. Now, this is kind of an apples to oranges comparison, but it should give you a good idea of the scale. In financial terms, Outbrain, which is our parent company or our company currently, last year did over $1 billion in revenue. And this system, this real-time bidder system, played a very important role in achieving that. So impressive as these numbers may sound today, 8 years ago, we started at 0. And to build it up to this level was a very gradual process that took a lot of time, a lot of energy, and a lot of hard work. So obviously, for us as an engineering team, there is an incredible amount of lessons we learned through this process. But because the time today is limited, I just want to focus on one very specific insight. And that is, as when we started this product, how we approach things and how we approach things in the middle of our journey and how we approach things now are 3 very different things. In fact, we can take our experience and we can divide it into 3 distinct phases. So I want to take you through those phases now. So the first stage I call the early phase. So we began building this product in 2014, and the first thing we did was to organize a hackathon. And the reason is because people say that when you want to cut down a tree, you first want to sharpen your axe. And similarly, we felt that if we want to build this thing well and make sure it has a chance of succeeding, we should be very careful about choosing what tools we work with. And that's why, even though we were under pressure to start building as soon as possible, we still decided to take 1 week to organize this hackathon and to evaluate the different technologies that we are and decide which ones we're actually going to use. So when it comes to choosing the tools, we had several criteria. The first one was to decide to check if the tool allows you to iterate quickly. Because when you're building something new from scratch, it's really important that you can get something in front of your customers as quickly as possible. The other criteria was how much experience do we already have with this thing? Because we wanted to have a good mix of stuff that we're familiar with and is not risky to use, we know what to expect from it, but also try some new things which can bring additional value. So for example, at Zemanta, up to that point, we used Python very extensively. So we had a lot of experience around that. But in addition to that, so we decided to keep Python, but in addition to that, we also added AngularJS, Golang, and some other new things. And the third criteria, which is maybe a bit surprising, is this thing going to scale? And this question is important because certain tools are great at fast iteration and are great in the early stages, but they would be very painful to use to maintain a large code base in them. So the bottom line here is that choosing the right tools is extremely important, and you should make sure you invest enough time in that. Because on the one hand, you need to ensure that these tools are enabling you to iterate quickly. On the other hand, if you're successful, you will be stuck with these tools for a long time. So you should think about the long term as well. So there were a few other considerations we were thinking about. One of them was the team. So the team was comprised of 8 engineers, and all of them had a similar profile, which I call the generalized specialist. And what this meant is that each of us had a very specific superpower, like backend, frontend, machine learning, infrastructure. But at the same time, all of us were full stack in the sense that we could get work done on any part of the code base. And when you're starting out, this is extremely valuable because it gives you a lot of flexibility. On the other hand, it enables you to it means you have experts in every area. So the other consideration was architecture. Here, we decided to go with the simplest possible option and to just put just enough structure in place to keep things under control. Because we knew it's really hard to predict what kind of an architecture you're going to need in the future, and architectures generally are quite easy to evolve. In terms of infrastructure, we decided to go with the cloud because we wanted to optimize for fast iteration. And we chose Amazon Web Services specifically. And the interesting point to mention here is that we didn't really care too much about the costs. Because even if we were being very inefficient with our infrastructure, the scale was so small that in the end, it still doesn't add to a lot of cost. And the last thing was the development process. Again, here we wanted to optimize first for fast iteration. So we did certain things like keeping our code reviews very lightweight. The other thing was to try to only unit test specific parts where we had critical business logic and we didn't write unit tests for front end, for example, and so on. And the other thing is we tried to optimize for autonomy by enabling all engineers to work on any part of the code base, and also by enabling engineers to deploy the whole application at any point in time with just a single command. Sorry. So the key point here is that every choice we made around tooling and approaches of how we work was made to help us learn and iterate faster. And as we started executing, we managed to, because of our choices, to build the first version of the product and onboard the first users within less than 1 month. And because of our choices, we were also able to very quickly adapt to any feedback that we were getting from the market. And as a result of all that, we then managed to gain some traction and started to grow and then started to scale more significantly. And thus we entered the second phase of the journey, which I call the growth stage, the growth phase. And for us, it began on July 25th of 2017. And that's a very specific date because that's the day we got acquired by Outbrain. And so literally overnight, we went from being just a small startup of 25 people to being part of this large global company with over 800 employees. So Outbrain had very big plans for us. It was clear that our product is something our customers want, and it's valuable to them. The question now is whether it will scale. So we had some pretty aggressive goals set for us. The goal for the first year was to basically double the amount of advertising spend going through our system. And then the goal for the second year was to double that again. So we had to make a few decisions to achieve this. The first one was, how do we actually want to work with Outbrain? Because you see, the best thing about big companies is the resources. In big companies, you have a dedicated department or a team, or at least a person for almost everything. So the downside of that is, of course, that the increased complexity that comes from this, which leads to lower speed of execution. So thankfully, we as a team were given a lot of autonomy on how to approach things. In each specific area, we could decide whether we're going to take advantage of the resources that Outbrain can provide, or we could decide to stay independent and keep rolling on our own. So in most cases, we actually decided to go with the second option. That's because we felt that in order to keep up with this growth that we were expecting, we will need as much autonomy as possible. So as an example of that, Outbrain has 3 major data centers and a dedicated department of 40 engineers that manage this infrastructure. And we had an option of taking advantage of that and theoretically taking the burden off our team. However, in the end, we still decided to not do that and to keep managing our own infrastructure. And the reason for that is because we felt that by staying independent, we could move faster. And it turns out that moving fast as possible, is extremely important when you're trying to deal with hypergrowth. And so, over the next few years, our product indeed saw very fast growth. Every month, we had more of everything. We had more ad spend, which was great, but we also had more data, more ads in the system, more users, more bid requests, and so on. In fact, our growth, average growth over the first few years was over 100% per year. So keeping up with all of that was very challenging. At every point in time, it felt like there's at least one part of the system that's struggling to keep up with all this load, because it was simply built with very different assumptions in mind. So because we architected the bidder in a way to be as horizontally scalable as possible, a lot of these issues were easily solved by simply throwing money at the problem, or in other words, adding more machines. But in other cases, our centralized parts were starting to become a problem, which is much more difficult to fix. So for example, at some point it became clear that one of our centralized services, called the banker, is not going to scale past 1 million queries per second, which was the number we were very rapidly approaching. So we had to swarm on that issue, try to find a solution, and when we did, we also had to implement it very quickly before the rising traffic would catch up. And that's just one example, but we had situations like that constantly. So in other words, we were in this constant mode of trying to predict what's the next bottleneck and where it will be, and then shifting our limited time and resources onto that issue and trying to fix it before it was too late. So in terms of technology, during this phase, we also had to introduce a bunch of new tools to better deal with the scale we were facing. But the key point here is that we introduced new things only when it was necessary. We always tried to first scale the existing tooling and try to make it work at the new scale levels. If we couldn't, then we started thinking about adding something new. 2 other things changed in this period of time. One was the architecture, which was constantly evolving based on our needs and based on the bottlenecks we were facing. The other one was actually the team. Sorry. The other one was the team. So the team, as in this phase, we scaled the team from just 8 engineers to almost 50, it became clear that we need more experts in specific areas. So we started to grow and to hire and to add more specialized people to the team. So keeping up with growth by itself is not enough. You also need to do it sustainably. By that, I mean 2 things. One of them is cost efficiency. So as we were growing, it became very painfully obvious that the cloud is simply not going to work for our use case. It was simply too expensive. So one of the early decisions was to replace the serving infrastructure of our bidder with the on-prem servers that we were managing ourselves. And this decision alone cut the costs of this part of the infrastructure by about 80%, which at today's scale would translate to millions of dollars per month. And this is another example of the trade-offs we were constantly facing. So on the one hand, this move slowed us down. On the other hand, it was very important because of the huge savings in cost. And the other aspect of sustainable scaling is stability. So when you're smaller, downtime is bad, but it's not a catastrophe as long as you can get up and running decently fast. But as you scale, each hour of downtime starts costing you more and more. So to address this, aside from investing more in testing and in monitoring, a very important thing was a consistent practice of blameless postmortems. And what this means is essentially that when you have any kind of a production issue, and after we fixed it, we would bring all the relevant people into a room and discuss what happened, why it happened, and most importantly, how we can prevent it from happening again. And in this way, we were automatically making our system more resilient over time. So the bottom line for this phase 2 is very simple. Your main priority is to unblock growth and try to do that in a sustainable way. So despite all the challenges, in the end, things turned out really well. We managed to achieve the ambitious goals that were set for us. In fact, our ad spend, so the amount of spend through our system, increased by more than 15 times in the first 4 years after the acquisition. And over time, our growth then started to slow, and things started to become a little bit less crazy. And this marked the transition into the next phase of our journey. So in 2021 came another major milestone. We went public on NASDAQ. And by we, I mean Outbrain. And this, in my eyes, was the start of this next phase, which I call the mature phase. Because you see, in the growth phase, as I was describing, the key is to move fast, to resolve issues as quickly as possible, and to unblock growth quickly. But that comes with a cost. Because you're doing everything in a hurry, a lot of the solutions and systems and processes that you introduce in that way are not built in the most optimal way. And at the time, this is a trade-off that you're willing to make. But as the growth slows down, and then the speed of execution suddenly isn't the most important thing anymore. Instead, this is where we start focusing on stability and robustness and compliance and efficiency. Or in other words, on building the thing to last in the long run. So for example, in our case, what this means is that maintaining our own infrastructure in the growth phase made a lot of sense. It gave us a lot of autonomy, and it enabled us to actually survive the scale that I was describing. But now that the growth is slowing down and things are stabilizing, it's actually becoming a big burden on our team. So we are now more focused on leveraging Outbrain's infrastructure because that's simply more efficient in the long run. Same goes for other things like architecture, where we're also trying to over time, merge it together more and more. And ultimately, this also extends to the company level. That's why we are currently in the process of rebranding from Zemanta to Outbrain, to show that we are not operating as a separate unit anymore, but that we've become a critical part of the whole. So to summarize phase 3, as your product and technology matures, speed of execution is less important, and building things right for the long term becomes the main focus. So what I want you to take away from all of this is that new things are often or usually built in 3 phases, and each of these phases requires a different approach. When you're building something from scratch and starting something new, your main priority is to figure out what your customers actually want. To do that, you need to be able to move very quickly, to iterate fast, and to learn fast, and have fast feedback loops. And a good way to do that is to really ensure that the tools you use and the approaches of work that you use and choose are going to support that as much as possible. At the same time, at this stage, you don't really need to worry too much about building things perfectly. So things like stability, efficiency, test coverage, code quality don't really matter at this stage much. So once you prove you've got something that customers want, it's time to scale. And here, your main priority will be keeping up with all this growth that is now happening and worrying or trying to make sure that your system doesn't break too much. And what you can expect here is that you'll face new issues constantly, and that your focus will be on finding quick solutions that will last you until the next order of magnitude. And finally, once your growth slows, you enter into the mature phase. And finally, this is the time where you can start focusing on building things right for the long term. And it's the time where you can afford to trade the speed of execution for robustness and for efficiency. So at every phase, you need to optimize for different things. And that impacts how you work, what tools you use, and who you work with. So to conclude, whatever you're building, whether it's a company or a product, or even just a feature, all of this that I described also applies to features, take these principles to heart. Try to consider what phase you're in, and then try to adjust your approach accordingly. And with that, I'm sure you will find success. Thank you.
Wow, what an interesting session, and some very conflicting statements in the meanwhile as well. I saw that they needed to carry one guy out of the room when you said that you moved back from the cloud to on-prem servers. So I'm assuming there's going to be some interesting questions as well for you in the crowd tonight, especially because you've essentially led the team in all of these different stages of the journey. So you have a lot of experience that many of us don't have in the same capacity today. So without taking any more of the audience's time, let's see who's going to be the first one to ask away.
Hey, can you hear me? Yeah.
Yes.
Okay. So my question is, in the end, how did you guys manage to achieve that great scalability? I mean, at some point, I believe you had like 4 million requests per second. That's really impressive. Yeah.
Yeah. Okay. Yeah. So I didn't dive into the technical details too much in this talk, but it's a good question. I think essentially the answer is horizontal scalability. So we try to build. I mean, the system has many layers, but the serving layer, is actually built in a way that each node in this layer is as independent as possible. Which means that in theory you can just keep adding more machines, and you can get to the number that I mentioned, which is 1,000 machines, and each of them can independently serve traffic. So it means that this way you can actually scale pretty well. How we achieve that is essentially that these machines are very independent in a lot of ways. So they are not really doing any querying of the database. They have all the information that they need loaded straight into memory, which happens periodically, and similar solutions like that. And I think that's the main. Yeah.
Yeah.
We need to do another talk with more technical details, I think, to go into that.
Yeah. Great explanation. Thank you very much. Okay.
And we can do that at another time, I think so. All right?
Hey, great talk. It was very interesting. I had
Thank
written
you.
down because I forget things. So, what system you had in place to predict the bottlenecks, and how soon did you start to monitor these bottlenecks? Were you already planning 4 million requests per second?
So were we planning? No. I mean, depends on when you mean. Like at the beginning, we didn't dream that we could ever get to this level in the earliest stages. But when we started getting to 200, 300, 400,000, we started thinking, yes, we think million is coming. We think this is realistic. In terms of the bottlenecks, so we had a lot of monitoring, like general monitoring all across our systems. We have a very strong culture of that. So we were simply just observing these metrics and seeing where things are starting to break. For example, if we had a process that syncs data from one point to the other, and that process used to take 5 minutes, and now it's starting to take 50 minutes, and obviously this is not going to keep working for a very long time. So we started focusing on that issue. But nothing more sophisticated than that, I'm afraid.
Thank you.
Can you hear me? Okay, great.
Yeah.
Nice talk, by the way. And my question was, why did you merge with Outbrain when you did? What was the main benefit then?
So the truth is that this is still ongoing. It's actually only starting. So up until, I'd say, last year or so, we were still working mostly independently. But as I was explaining in the talk, as the value of autonomy, of our own autonomy, became less important, we saw that there are certain benefits in merging with Outbrain. So a concrete example, again, would be around infrastructure. So when we were managing our infrastructure independently, it gave us a lot of flexibility because, to be concrete, when we were running out of servers, to get these servers in Outbrain, it was a very bureaucracy-heavy process that we had to go through, and we had to do. And if we were independent, if we were managing our own infrastructure, which we were in case of some data centers, we could just do it ourselves. We had 3 people in the team who were handling this, and it got done. So this is what I mean by, autonomy that enables speed of execution. But lately, so what's happening, the flip side of that is that then you have 3 people handling a huge number of servers, and it's just too much. And the proper solution here, where speed of execution is not so important anymore, seems to be to merge this with Outbrain and get that huge department of 40 engineers to handle these things for us as well. So there's no clear cutoff point where this doesn't make sense and then starts making sense. But I think since we did the IPO and at the current level of scale, we are about there. And this is where we're trying to move.
How did you handle the database loads? A bit more technical, but...
So I think the simplest explanation is to basically say that all of these most intensive parts, so the serving part that actually handles 4 million bid requests and does 1 billion predictions per second, does not actually do a lot of communication with databases. Because if it was doing that, databases would definitely become a bit bottleneck. But instead what we did, we tried to put all the information that these bidders need to properly respond to these requests in basically a large file, which is then loaded onto each machine and put into memory. So basically each machine is not querying a database, but it's querying its own memory to get the information it needs. Writing is a bit different here, but in our use case, what actually works is that we just collect, each machine just writes a log of all the events that happened and pushes that onto some central points, which currently is still S3. And this is where I was talking about 150 terabytes of data generated per day. This is what happens. So these 1,000 machines are generated logs and pushing that to some central point where it's then being processed through Hadoop and similar things.
Cool, smart approach.
So, great talk. I want to ask if you have looked into hybrid cloud to combine the cheapness with local on-premises with quick growth in the cloud.
So not sure what exactly you mean. You mean using both cloud and on-prem servers, or do you mean something else?
So as a way to be able to quickly get the servers set up, but then as soon as you get these cheaper services from Outbrain, you can just migrate.
Oh yeah, I got it. Okay. We're not really doing that. We were kind of doing it in the past in some cases. So a couple of years ago, we had only 4 data centers, and we decided we need a new one, and we need it soon. So the first version was built on AWS. And then when it started to grow, in the meantime, we built an on-prem data center there. But why we don't do it in general is just because it's more complex. So now it's much simpler. We have this data center and a bunch of machines, and we need to predict far enough in advance, and usually this is like 3 to 6 months, how many machines we're going to need. And as long as we're doing that, it's much simpler than actually trying to have this hybrid approach. So I don't know, maybe sometime in the future this would make sense, but we didn't get to that.
So you mentioned production issues cost a lot of money. And what's the usual process when you encounter an incident? Do you have a on-call, and then if they don't, if it's not in their area of expertise, do you what's the usual procedure?
Yeah, it's a good question. So we do have on-call, and we try to basically have it. It's based on teams mostly. So this means that whenever something goes wrong in one of the services or one part of our system, it will be the relevant team that will be paged. And that team will then try to fix the issue. And usually, I'd say 90% plus cases, they're able to handle things independently and very quickly. But of course, every so often, we have broader issues that take our system down for a lot longer. And in that case, usually, everybody starts jumping in, from a bunch of engineers to the execs, the CTO, and so on. And it's just basically a large number of people in a single Slack channel coordinating and trying to fix the issue by trying to think of as many possible solutions as possible. So yeah, this happens also. One example of that is a couple of years ago, we had an incident that was actually caused by a bug in the cloud provider's code that took our whole system down for 8 hours. That was a very fun time, and cost a lot of money.
Jesus, your idea of fun is quite different than mine.
That was sarcasm, but yeah.
Great talk. I mean to ask, because of your uptime, have you managed to introduce continuous deployment?
Yeah, good question. So depends on how you define continuous deployment, but we actually had something like this from the very beginning. When I was talking in the first phase, we wanted to enable every engineer to deploy as quickly as possible, so to increase engineering autonomy. And we kept this system up to today. So essentially what it means that this system of 1,000 servers, right now any engineer can go into Slack and can write a deploy bidder, and this system gets deployed with the latest version from our repository. And the issue right now is maybe that these deploys take around 15 minutes, I think, or 20 minutes, which is more than we would like. But still, it's pretty impressive, I think, given the scale of the system.
Yeah, hi, great talk. So just a quick question: how did the hackathon help you to pick the right tools?
So essentially, the hackathon, I probably should have explained it better. The hackathon was not about go and build whatever you want, but it was about deliberately testing and evaluating specific technologies. So for example, we dedicated one engineer, actually that was me at the time, to evaluate 3 different front-end frameworks. I think it was AngularJS, Ember.js, and React. And then, I played with those tools, I tried to build some simple apps, and then I presented to the rest of the team what my findings were, and through discussion we then decided which one we want to pick. And we did the same for deployment tools, and for backend languages, and for clouds, and for everything else.
Great, thanks.
Hey, just a question. Are you deploying services on bare metal using virtual machine or Kubernetes, and why?
Yeah, good question. So the answer is a bit complicated because we have many different services. And when I was saying we moved away from cloud, that's only for the serving layer. So a lot of our services are still on AWS, although we are trying to move away from that as well. But so when it comes to AWS, we do use Docker and we use Kubernetes for that, or some AWS version of it. When it comes to the bidder, the bidder is written in Golang, which means that when compiled, it compiles to just a single binary. And there is simply no need, because each machine in the cluster is running one instance of the bidder. There is no need for Kubernetes or virtualization or anything like that. We simply take this binary, we drop it onto the server, and that's it.
All right. Any more? Okay.
Hey, so you mentioned that you've changed a lot from the early days. What's something that you really miss, and what's something that you really don't?
Good question. What I really miss is just that when you're small, things just happen so quickly. We were literally, all 8 engineers on that team were in the same room all the time. And that was before COVID, before hybrid working mode. So we were actually there 5 days a week. And an incredible amount of ideas and collaboration and learning happens this way. That's when your team grows to 5 or 6 times that size, these things become much more difficult. What I don't miss so much is, again, the lack of resources that I was mentioning. So as a startup, you are always constrained. So everything, everything, you just have less money, I would say. And as part of the big company, even though things are starting to take longer, some things are really nice that are just handled for you, or you can just afford because you are in a bigger company.
Yeah, hi, great talk. My question is about breaking changes. So how did you manage to mitigate the downtime or maximize uptime when the breaking changes occurred? Or if there weren't any, how did you manage to do that?
So I think mostly we try to design all the changes in a way where we could avoid breaking changes. That's by far the best option. And right now I can't really think of a case where we would need to shut down our system to handle a big change like that. Mostly it's just, basically running things in parallel. So we have, let's say, what we're doing right now, we have this old data pipeline that we're now trying to improve. And we are building the new data pipeline in parallel, and we are running both of them at the same time. And when we are sure that they are both the same and everything works 100% okay, we're just going to shut down the old one. And I think this translates to many different cases. So even if you're doing some change in the code, you can do it in the old way, put in the code for the new way, do it in parallel, and then delete the old flow. But yeah, I'm sure there were some breaking changes at some point, but I can't remember them now. Sorry.
Before you mentioned that there were like 3 engineers who were handling infra, right? And it was too much for them and you switched to on-prem, right? Or started thinking about it. Why did you decide to actually hire more engineers to handle that so that you would still have that autonomy going forward?
So I need to clarify a little bit. So when we were on the cloud, I think we actually had like 2 engineers working on that. And then we moved to on-prem, and again, for the serving layer. And then we expanded that team to 3 or 4 engineers. And so we didn't actually, what I'm trying to say, we only had to expand this team slightly. People would expect that when you go from cloud to on-prem, you need to, dramatically increase your team. For us, that was not the case, because on the one hand, when I said we didn't work with Outbrain at all, we mostly didn't, but the truth was that we used their data centers, and they still were handling the very lowest level things for us. So they were handling, setting up racks and putting servers and plugging cables in, but everything else on top of that we were doing. Not sure if I answered your question. So we can take it offline. Sorry.
All right, one last question. But before we do that, I'm going to reserve the right to ask a stupid one before. Do you think your problems with scaling could have been avoided by using a simple middle-out compression algorithm instead?
I don't know. I don't think so. I mean,
I'm just kidding.
I know, but I'm trying to give you a smart answer. I can't think of it. Sorry.
Thank you for the talk. So maybe just another question regarding the early stages. So if I got it correctly, you're kind of in a startup mode, breaking things, iterating fast, and this was the main priority of the team. So I suppose that probably in the mature stage, you have to rewrite quite some things to make it more robust, resilient, and so on. So I'm just wondering if you would start it from scratch again, would you stick to some, I don't know, to some standards that you would not compromise? So
yeah.
Is there anything that there, I don't know, coding standards, conventions, and so on that there should be from the beginning?
Yeah, so I'd say this is essentially it's a scale. So we didn't actually like throw all the standards out the window in the beginning and just hack things together. As I mentioned, we still did code reviews, even though we kept them very lightweight. We still wrote unit tests, even though we didn't write them for all of our code. So I think it's a spectrum. You don't need to either don't do these things at all or do them 100%. In the early stages, this slider is just moved on more on this side towards less following of code practices and unit tests and so on. So as we grew, we're just moving more to the other side of the spectrum. We're putting more emphasis on those things. So.
Thank you so much, Florian, for a great, insightful session and for the wonderful answers. And ladies and gentlemen, please let's give it up for Florjan Bartol, the VP of Engineering and Outbrain, and his session on scaling to 4 million requests per second. Wonderful, thank you.